In order to open the safe, you need to guess the 10-digit number that needs to be entered in the figure shown below. Here are the clues for cracking the code to this safe. Clue number 1. The first cell indicates the total number of zeros present in the passcode. The digit in cell marked 1 indicates total number of ones present in the passcode. The digit in cell marked 2 indicates total number of 2s present in the passcode, and so on to the last cell, whose digit indicates the total number of 9s present in the passcode. Clue number 2. The answer is unique. Take a moment to try and figure out the solution. You may pause the video if needed. Alright, so let's first take a look at the last cell marked as 9. The number present in this cell tells us how many times the digit 9 appears in the passcode. Could this number be greater than 1? Case 1, say, this cell has a number x, which is greater than 1. This tells us that there are at least 2 cells containing digit 9. This means 2 of the numbers from 0 to 9 appear 9 times in the 10-digit passcode. This would mean there are at least 18 digits in the passcode. This is a contradiction, as we only have 10 digits in the passcode. So this is an invalid case. So the number in the cell marked as 9 can only be 1 or 0. Case 2, say the number in cell 9 is 1. This means there is a cell containing the digit 9 somewhere. Which of those cells could contain the number 9? Case 2a. Say the cell which contains the number 9 is a cell which is marked with a number other than 0. Say that non-zero cell is the cell number x. This would then mean that digit x would appear in 9 cells, implying that the digit x would be placed in all of the cells except the last cell. This would again lead to a contradiction because we would then run out of cells to accommodate multiple digits, appearing more than once, after we have placed the digit x in 9 cells. So this is an invalid case. Case 2b. Say the cell which contains the number 9 is the first cell marked with 0. This would then mean there are 9 zeros in our passcode. This is also a contradiction because we only have 8 spaces left in the passcode as the other 2 places already contain digits 1 and 9. So case 2 is invalid. This brings us to a conclusion that the cell 9 has to contain the digit 0. So we place 0 in the last cell, which also tells us that the digit in cell 0 is a number greater than or equal to 1. Now, working from right to left in a similar fashion, let's check the cells marked with 8, 7, 6, etc. If we check cell 8, we can observe that, even this cell, cannot contain a digit greater than 1, otherwise we would need at least 16 digits in the passcode. Next, if cell 8 has the digit 1, then this would mean that the digit present in cell 1 must be greater than or equal to 2. Note that it cannot be 1, otherwise, we would have 1 appearing twice, contradicting cell 1. Arguing as we did in the case of the cell 9, the digit 8 can only be placed in the cell 0. As can be seen from the figure below, we already have at least 4 cells containing a digit greater than or equal to 1. So, we will run out of cells to place 8 zeros. So, this too is an invalid case. This brings us to a conclusion that the cell 8 must contain the digit 0. Following similar lines of reasoning, you can easily conclude that cell 7 also must contain the digit 0. Now, if we check cell 6, we can observe that, even this cell, cannot contain a digit greater than 1, otherwise we would need at least 12 digits in the passcode. If we place digit 1 in cell 6, then the digit 6 must belong to cell 0, otherwise, we would have more numbers to accommodate than cells available. Let's try placing 2 in cell 1, as this cell must contain a digit greater than or equal to 2. Now, seeing that we have a digit 2 present, let's place digit 1 under cell 2, since this satisfies the requirement for digit 1 as well. As there are a total of 6 zeros in the passcode, let's fill in the remaining 3 cells with zeros. So writing down the digits in order, we get 6, 2, 1. 0, 0, 0. 1, 0, 0, 0. Upon verification, all digits of this arrangement satisfy the rules mentioned at the beginning, so this is a valid answer to this problem. In fact, this is the only code that satisfies the requirements. Congratulations to you if you figured this out. Bravo! Thanks for watching. If you liked this video, please hit the like button and subscribe to this channel to get more related content.